So in this video, I'll discuss the concept of the photoelectric effect. So the photoelectric effect was the concept used by Einstein to test Max Planck's idea that light has this particular property called discreteness or quantization. Okay? So yung quantization kasi, it's a characteristic of a particle. Kasi particles are discrete. They are not continuous entities like waves. Okay? So since light is exhibiting discreteness, maybe light has a particle property. Yun yung parang gustong i-explore ni Einstein using this photoelectric effect. So according to the photoelectric effect, if you introduce a specific wavelength of radiation sa isang metal na may work function phi, okay, so depending on both the incident light energy and the work function, makakapag-eject ka ng electron with a specific kinetic energy. So paano mo ma-determine yung kinetic energy niyon? So the work function is the minimum energy required to expel the electron from the metal. Okay? So, kailangan malagpasan yon ng energy ng incident radiation para makapag-expel ka ng electron. So, yung difference ng energy ng inyong incident light tsaka nung metal, yung work function ng metal, yun yung magiging energy ng inyong ejected electron. Okay? So, what is the energy of your incident light? According to Einstein and Planck, it is in multiples of h times the frequency of your light. So, E is equal to h nu. So, yung nu, that's the frequency of an EM wave or an electromagnetic wave. So, pwede tayong mag-substitute ng C over lambda. So, E can also be expressed as HC over lambda. Okay? So, aside from the energy, meron din tayong work function. So, the work function depends on the nature of the metal. So, kapag mas malaki yung energy ng incident radiation sa work function, may ma-expel tayong electron doon. And the formula for this photoelectric effect is the kinetic energy of the electron. So E sub k, which is the kinetic energy, is equal to the difference between the energy of the incident radiation minus the work function of the metal. So kung ano man yung matirang energy, yun yung magiging kinetic energy ng iyong electron. So the kinetic energy of the electron can be expressed as 1/2 times the mass of the electron. So, ang mass ng electron natin ay 9.11 times 10 to the negative 31 kilograms. Okay? Yun yung ating measured value ng mass ng electron times the square of the electron's velocity upon ejection. Okay? So, please remember this equation. Okay? Yung kinetic energy ng electron is equal to the difference between the energy of the incident light and the work function of the metal. Of course, kung mas malaking work function ng metal dun sa incident light, wala tayong may eject na electron. And kung equal yung work function ng metal dun sa energy ng incident light, wala rin tayong magiging kinetic energy value. So, zero yung kinetic energy, hindi pa rin ma-expel yung electron. So, the actual kinetic energy can only be achieved, or a minimum kinetic energy of the expelled electron can only be achieved kapag mas malaki yung energy ng incident light. Okay? So, what are the features of this photoelectric effect that could exhibit particle nature of your light? Okay? So, number one, the ejection of the electron happens immediately after the incident radiation reaches the surface. So, according to classical physics, okay, pagka nagkaroon ka ng incident radiation, okay, magkakaroon tayo dapat ng lag time kasi a-absorb muna nung inyong electron yung wave or yung energy of the light wave, tapos matcha-charge siya bago siya ma-expel. Okay? So, ibig sabihin, wave nature pa rin yung light dito kasi na-absorb lang siya nung electron bago siya ma-expel. So, we need to have the lag time kung classical physics to. Pero, according to the photoelectric effect, wala tayong lag time. So, nangyayari lang yung walang lag time kapag ka collision yung process. Ibig sabihin, talagang tinulak ng ating light yung electron palabas ng ating metal or tinapon talaga siya ng ating light palabas ng metal. Okay? So, imbes na charging yung nangyayari, okay, collision yung seemingly na naganap. Okay? Nag-collide yung light dun sa ating electron. Kaya siya tumalsik dun sa ating metal. So, collision will only happen if your light is a particle. Okay? So, since according to the experiments, wala tayong lag time or yung time required to charge the electron enough for it to expel or be ejected dun sa ating metal surface, the light may have acted like a particle. Okay? So, another one, the kinetic energy of the ejected electron does not depend on the intensity of the light. So, ibig sabihin, kung classical mechanics kasi to, the more intensity of the light, the more light waves are available. So, mas mabilis dapat ma-charge yung electron at mas mabilis dapat or mas marami dapat yung iyong energy na ma-absorb. So, ibig sabihin dapat nag-i-increase yung kinetic energy ng iyong ma-eject na electron. But this is not the case sa photoelectric effect. So, kahit mababa lang yung intensity, basta mataas yung energy, na-expel agad yung electron. Okay? So, this is characteristic of particles. Why? Because even if there are only a few particles, if the energy of the particles or if the speed or if the momentum of the particles are very large, the collision will be very effective or it will be effective enough to elbow out the electrons. Okay? So, hindi kailangan ng intensity doon. So, the intensity will only introduce more light. Okay? So, marami kang light waves or marami kang light particles, pero kung hindi enough yung momentum nila para mag-expel ka ng electron, okay, hindi pa rin mangyayari yung photoelectric effect or hindi pa rin ma-expel yung mga electrons or wala kang enough energy to remove the electrons from your metal. Okay? So, from this diagram, we see that if the work function is greater than the energy, wala kang ma-eject na electron. So, the higher intensity will only introduce more light waves. Okay? So, hindi siya related dun sa energy ng iyong light. So, more electrons will be ejected if the light waves have enough energy. Pero kung hindi pa rin enough, kahit gaano siya ka-intense, hindi ka magkakaroon ng ejection ng electrons. Okay? So, the lower the wavelength, the higher the energy. So, the higher the kinetic energy of the expelled electrons. So, kahit konti lang yung intensity, kapag tinaas mo yung frequency ng inyong incident light, mas mabibilis yung mga na-eject na electron. Okay? Ibig sabihin nun, mas mataas yung kanilang kinetic energy. Okay? So, that is for the features of your photoelectric effect. So, here we have some sample problems. So, ang gagawin lang natin, i-apply lang natin dito yung mga equations na na-discuss natin sa photoelectric effect. Okay? So, for number 1, a certain metallic alloy with a work function equal to 1.25 electron volts was subjected to 280 nanometers incident radiation. So, 1 electron volt is equal to 1.602 times 10 to the negative 19 joules. So, this particular unit of energy is used kung individual electrons lang yung pinag-uusapan natin kasi masyadong maliit yung kanyang mga values ng kinetic energy. So, magandang unit ang electron volts kapag individual electrons ang kinukuhanan natin ng energy values. Okay? So, for letter A, calculate the energy of the incident light. So, in this case, we will use this equation. The energy of the incident radiation is equal to H times the frequency of your incident radiation. So, H is the Planck's constant. We can also use this kasi mas applicable to sa problem since given ay wavelength. So, that's H times C over lambda. Okay? So, substituting the values, we have the Planck's constant, 6.626 times 10 to the negative 34 joules second per particle. The particle here is the electron times the speed of light, 3 times 10 to the 8 meters per second. And of course, the wavelength of your incident radiation, which is 280 times 10 to the negative 9 meters. So, meters ang gagamitin natin. Again, 1 nanometer is equal to 1 times 10 to the negative 9 meters. So, pwede nyong ilagay na lang yung scientific notation na times 10 to the negative 9 kung ayon yung mag-convert muna. Okay? So, mas madaling technique ito. Okay? So, the energy of the incident radiation is 7.099 times 10 to the negative 19 joules per particle. So, we can convert this to electron volts by using this conversion factor. Yung 1 electron volt is equal to 1.602 times 10 to the negative 19 joules. Okay? So, by using the conversion factor, makakancel yung ating joules. Okay? So, yung electron volt, yung matitira, yung particle that is not necessary dun sa unit kasi alam naman natin na yung electron lang naman yung ating pinag-uusapan dito. So, 7.099 times 10 to the negative 19 divided by 1.602 times 10 to the negative 19, we have 4.432 electron volts for letter A. So, for letter B, calculate the kinetic energy of the ejected electron. So, gagamitin na natin yung photoelectric effect equation na kinetic energy of the ejected electron is equal to the energy of the incident light minus the work function of your metal alloy. So, isusubtract lang natin yung 4.432 electron volts sa 1.25 electron volts. we will get 3.182 electron volts as the kinetic energy of your ejected electron. Okay? So next problem, we have another metallic alloy subjected to 250 nanometers incident radiation. So the velocity of the ejected electron was 9.27 times 10 to the 5 meters per second. Okay? So for letter A, calculate the kinetic energy of the particle. So meron tayong velocity, and we know that the mass of the electron is 9.11 times 10 to the negative 31 kilograms. So we can use the kinetic energy is equal to 1/2 times the mass of the electron times the square of its velocity. So substituting the values, we have this 9.11 times 10 to the negative 31 kilograms for the mass of the electron and 9.27 times 10 to the 5 meters per second. Tapos isa-square natin yung velocity. So we will get 3.914 times 10 to the negative 19 joules per particle. So kung i-convert nyo to sa electron volts, you will get 2.44 electron volts. Okay? So for letter B, calculate the energy of the incident light. So meron tayong wavelength ng incident light. We will just use E is equal to hc over lambda or h nu. So mas maganda gamitin to since given ay wavelength. So substituting the values, we have 6.626 times 10 to the negative 34, that's h. 3 times 10 to the 8, that's c. And yung ating 250 times 10 to the negative 9 meters, that's the 250 nanometers. So you will get the value of 7.9512 times 10 to the negative 19 joules per particle. So kapag kinonvert niyan sa electron volts, you will get 4.963 electron volts. So finally, for letter C, calculate the work function phi of the metal alloy. So ang gagawin lang natin dito, i-rearrange lang natin yung photoelectric effect equation para makuha natin yung work function. So phi is equal to the difference between the incident light and the kinetic energy of your ejected electron. So kapag sinubtract natin ang 2.44 from 4.963 electron volts, ang makukuha nating value ay 2.523 electron volts. Okay? So this is my discussion on the photoelectric effect. So sa susunod na video, I'll discuss the line spectrum for hydrogen. So that's further proof that light may be quantized. Okay?